Now let's talk about 3.5 transformations of exponential functions. So in this section we learned to identify when functions can be expressed as a simpler base. We understood that exponential functions can be transformed, and we comprehended how to obtain transformations from f of x is equal to k exponent x, so the base function, to get f of x is equal to ak to the power of b times x minus h plus c. So we use these guidelines to determine the transformations, and based on these guidelines we knew that, for example, the function was horizontally stretched or whatnot. So if you don't recall, just pause the video now to review these guidelines. So now it says describe the transformations based on the base function. So in A, the base function is 3, and so we know that the h value is 2 and the k value is 7, which means that the 3 to the exponent x is going to be translated 2 units to the right and 7 units up. So next question, it says y is equal to 1 over 2 times 6 to the power of x. And now, so we know that because of the 1 over 2, it's only going to be vertically compressed by a factor of 1 over 2 to get the translated function. So in the next question, you're given the base function, and we have to obtain the transform. It asks us to describe the transformation to get that function. So we know that the a value in that function is 4, which means that it's going to be vertically stretched by a factor of 4, and then the b value in this case is 1 over 5, which means that it's going to be horizontally stretched by a factor of 1 over 5, and the h value is 5, which means that the function is going to be shifted 5 units to the right. So now let's look at a graphing situation. So in this question, it asks to graph y is equal to -1 times 2 to the power of x minus 2 plus 4. So we know that the base function is 2 to the power of x, and so based on that we can write the table of values for it by just subbing in values for x to get the the y values. So we know that the a value in this case is -1, and the b value is 1, the h value is 2, and the k value is 4. So, and this is useful for mapping notation to to actually graph the transform function. So in this case, the mapping notation is written here. So in this case, b is 1, right? So you just do x divided by 1 plus 2, which is the h value, and then -1, which is the a value, times y plus 4, which is the k value. So all I did to get these values was sub in like the 0 as the x value here to get them. So just repeat that for all the points you have, and then do the same thing for the notation for the y values to get the transformed coordinate pairs. So once you have that, the complete transform table of values, you can easily graph by just plotting the points. So 2 and 3 would be right here, and it's very simple to graph. So it asks us what the horizontal asymptote is, and the horizontal asymptote, we know that it's the k value, or the k value in the equation. So in this case it was 4, right? So this is the horizontal asymptote, which means that the graph is never going to touch 4, but it'll get really close. So now the domain and range is, for the domain it's x and r, because x can be all real numbers, and we don't have any restrictions on it because we're not giving any further information. Whereas range, it's y and r, y has to be less than 4 because of the horizontal asymptote.